Students, welcome. So let's try to solve these questions which are important for our coming exam. So there is a helium neon laser which is emitting average power. So we know the power of emitted laser is the rate of work done or work upon time. And we know work and energy is same. So energy of n number of photons divided by time. And n number of photons energy we can write as n h into frequency. So h nu is the energy of one photon divided by time. So our aim is to find n and the wavelength is given. So I can rewrite this as formula as power P equals to n h c divided by wavelength into time. Or I can write this number of photons n equals to power into wavelength into time divided by h into c. Let's substitute the values. So the power is given in milliwatts, so we'll convert in watt. So it will be 4.5 into 10 to minus 3 watt. Wavelength is given 6328 into 10 to minus 10 meter. And time is given 1 second, which is divided by h value is 6.63 into 10 to minus 34 joule second. And the speed of light is 3 into 10 to 8 meter per second. Speed of light is 3 into 10 to 8 meter per second. Now when we calculate, we'll get the value of number of photons is large, which is 1.431 into 10 to 16. Let's very fast, we'll go to the next question. We need to find the ratio of population. We have given temperature and the wavelength. So wavelength is given, we can write this as 694.3 into 10 to minus 9 meter. And temperature we convert in Kelvin. So 227 plus 273, which will become 300 Kelvin. Now we know the formula for finding the ratio of population is N2 upon N1 is e raised to minus delta E upon K into T. Delta E I can write as N2 upon N1 is equals to e raised to minus Hc upon lambda Kt, because delta E is h into nu or hc upon lambda. So when we substitute, we'll get this value as e raised to minus 6.63 into 10 to minus 34 into 3 into 10 to 8 divide by wavelength is 694.3 into 10 to minus 9. K is 1.38 into 10 to minus 23 and the temperature is 300. So when we calculate, we'll get this ratio of population N2 upon N1 as 8.82 into 10 to minus 31. Refractive index of core and cladding is given. So refractive index of core is N1 1.48. The refractive index of cladding is 1.45. Now the numerical aperture is N1 square minus N2 square. N1 square minus N2 square. So when we substitute, we'll get the numerical aperture comes out to be 0.9. 296. And the acceptance angle formula we know is theta 0 sine inverse of numerical aperture. So theta 0 will be sine inverse of 0.296 is 17.2 degree. Next we need to find the critical angle. So formula for critical angle is sine inverse n2 upon n1. So the critical angle comes out to be 78.6 degree. Now the next we need to find the fractional refractive index, and the fractional refractive index is n1 minus n2 divided by n1. So fractional refractive index comes as 0.0203. In Newton's ring experiment, the diameter of fifth dark ring and 15th dark ring we have given. Now we know the radius of curvature formula is diameter of 15th dark ring minus diameter of fifth dark ring divided by 4. P is 15 minus 10 is 10 into wavelength. So the radius of curvature will be diameter of 15 dark ring is 0.590 square minus 0.336 square divided by 4 into 10, and the wavelength will convert in centimeter. So I can write this as 5890 into 10 to minus 8 centimeter. And when we substitute and we calculate the value of R, the value of R comes to be the value of R will be 99.83 centimeter. Again, from Newton's ring, we have given the refractive index. Now for this, the formula we know as diameter of any nth order dark ring is 4R n lambda divided by refractive index of the medium. We need to find radius of curvature. So R will be diameter of nth dark ring into refractive index divided by 4 n into wavelength. So radius of curvature will become diameter of ninth dark ring is 0.58 square into wavelength is 1.33 divided by 4 into so ninth order multiplied by wavelength will convert in centimeter, which is 6000 into 10 to minus 8 centimeter. So when we calculate, it comes out to be 207.13 centimeter. Now for finding this gradient is I cap plus j cap plus k cap. So let's substitute. I cap will take 3 common, is equals to 3 I cap x square y minus y square x plus j cap del upon del y x square y minus y square x plus k cap del upon del z x square y minus y square x. Let's differentiate 2xy minus y square plus j cap x square minus 2xy plus there is no z term, so it will be 0. Now in this equation, we'll substitute x1. Wherever x will substitute 1, wherever y will substitute minus 2, wherever z will substitute minus 1. So when we substitute at the end, we'll get this value as the gradient of this scalar field is minus 24 I cap plus 15 j cap. Calculate the wavelength of de Broglie wavelength, which is associated with the particle of mass 1 kg in the speed. So we know the de Broglie wavelength is h upon mass into velocity. So 6.63 into 10 to minus 34 joule second divided by mass is given 1 kg multiplied by speed is given 10 to 3. So wavelength comes to be 6.63 into 10 to minus 37 meter. An electron is bound in one-dimensional potential well. We know the formula for energy of electron in dimensional potential well of infinite height is n square h square upon 8 ma square. For ground state, we'll take n1 for ground state energy. For ground state. So this formula for ground state will be h square divided by 8 ma square. So when we substitute, h is 6.63 into 10 to minus 34 square divided by 8 into mass is 9.11 into 10 to minus 31 and the width is given 2. We'll convert in Armstrong in meter. So 2 into 10 to minus 10 meter square. So the value of energy in the ground state will be 1.5 into 10 to minus 18 joule, which we can convert in electron volt. So if I'll write in electron volt, so I need to divide it by 1.6 into 10 to minus 19. So when I divide it by 1.6 into 10 to minus 19, it comes out to be 9.43 electron volt. Energy in the first excited state. So for first excited state, we'll take N2. So the formula for first excited state is 2 square into E1. So we'll get this value as 6 into 10 to minus 18 joule, or we can write in electron volt, which is 37.5 electron volt. An electron and a photon. So we need to find the momentum and energy. So for finding the momentum, we know for electron, lambda is h upon p. So I can write p equals to h upon lambda. So when I substitute, I'll get this value as 6.63 into 10 to minus 34 divided by wavelength is 2 Armstrong. So 2 into 10 to minus 10. So the momentum will comes out to be 3.315 into 10 to minus 24 kilogram meter per second. And the energy is p square upon 2m. So the value of p is 3.315 into 10 to minus 24 square divided by 2 into mass of electron is 9.11 into 10 to minus 31. So the energy associated with electron is 6.038 into 10 to minus 18 joule. Let's try to find out for photon. So for photon, again we write the same formula. Wavelength of photon is h upon p. Since the wavelength is same, so we'll get the value 6.63 into 10 to minus 34 divided by, we need to find the momentum. So we can write this now. This implies momentum is h upon wavelength. So we'll get the same momentum as for electron, which is 3.315 into 10 to minus 24 kilogram meter per second. But we know the energy of photon is h into frequency, or hc upon wavelength. So to find this, we have given wavelength 6.63 into 10 to minus 34 into 3 into 10 to 8 is the speed of light, divided by wavelength is given 2 into 10 to minus 10. So the energy of photon comes out to be 9.945 into 10 to minus 16 joule. An electron has a speed 400 meter per second. Uncertainty is 0.01. So we need to find the accuracy in its position. So what we have given? We have given delta V upon V is 0.01%. So 0.01 divided by 100. We know the uncertainty principle. Delta P is m into delta V. Multiplying dividing by multiplying and dividing by V, I can rewrite this as, so the momentum or uncertainty in momentum we can find is 9.11 into 10 to minus 31. Velocity is 400. Uncertainty velocity is 0.01 divided by 100. So uncertainty in momentum will comes out to be 3.644 into 10 to minus 32 kilogram meter per second. Now by applying uncertainty principle, delta x uncertainty in momentum, delta x uncertainty in position, delta p uncertainty in momentum greater than equals to h upon 2 pi. So delta x is greater than equals to h upon 2 pi into delta p. So we'll get this value of uncertainty in position is greater than equals to 2.895 into 10 to minus 3 meter. Predict the effect of electrical properties of silicon if every million silicon is replaced by indium. So we have given the conductivity, intrinsic conductivity is given 4.4 into 10 to minus 4 ohm meter. Now we know the number of impurities which are doped. We can find by dividing the concentration, which is 5 into 10 to 28 and 1 million is 10 to 6. So I can write this as 5 into 10 to 22. Now the formula for finding the conductivity for this p-type semiconductor now is mobility of holes, charge on holes and concentration of holes, or number of impurity concentration, number of trivalent impurity, number of impurity concentration. So the conductivity now, mobility of hole is given 0.048 and the charge is 1.6 into 10 to minus 19 into 5 into 10 to power 22. So the conductivity when we calculate it comes to be very large, 384 ohm meter inverse. So we can comment that conductivity increases. Therefore conductivity increases when, we can give the comment that conductivity increases when trivalent impurity is added. When trivalent impurity added. Now the one more question, that resistivity of copper is given. So we have given the resistivity 1.72 into 10 to minus 8 ohm meter. We need to calculate the mobility. We need to find the mobility of electrons. The number of electrons per unit volume is given 10.41 into 10 to 28 per meter cube. Now we already know the formula for conductivity is mobility, concentration of electrons and the charge on electron. So I can write this mobility as conductivity divided by N into E. And mobility I can write in terms of resistivity as 1 upon rho Ne, because we know conductivity is 1 upon resistivity. So when we substitute the values, the resistivity is given 1.72 into 10 to minus 8. Concentration is given 10.41 into 10 to 28. And charge is 1.6 into 10 to minus 19. So when we calculate, the mobility comes out to be 0.0035 meter square per volt second. Thank you, students. So please do comment, like and subscribe with your friends.